Today we will see what is there in the exercise of the lesson force and laws of motion. Okay, in the last class, okay, we learned the indexed questions. Okay, I think one question of the last that is second index question is remaining, that fourth question. So let's see that question first. Okay, page number 127. Okay, here the question is two objects of mass 100 gram and 200 gram are moving along the same line. Okay, here are the two masses. So we will say it as, okay, M1 and M2. Okay, so M1 is of, but actually it is 100 gram. Now you know that 100 gram must be converted into kilogram. So 100 upon 1000. Okay, so it is 0.1 kg. Okay, and the next is M2. Okay, M2 is equal to what it is given, that 200 gram. With 200 gram also it will become 200 upon, okay, 1000. So it is of 0.2 kg. Okay, understand? Now further what it is given, it is with a velocity. Now it is moving with a velocity. Moving with a velocity means u1. u1 is given that 2 meter per second and u2 is given that okay, 1 meter per second. Then further, okay, they collide. Okay, that means okay, they are moving. This is, so M1 is moving and M2 is moving. After some time they collide each other. M1 and M2 collide each other. Then this, here it is U1, here it is U2. Okay, then after collision further it started to move. Okay, so this is of M1, this is of M2. Okay, then this time the velocity will change. It will become V1 and it will become V2. Okay, so now what is V1 is after collision? Okay, V1 is equal to, what is V1 is equal to? It is of the first moves that velocity of 1.67 meter per second. Okay, then determine the velocity of the second one. That is, we have to find V2. V2 we have to find. Understand? Okay, this is what the, okay, the setup of the question. I hope you understand this much. Okay, now what here we have to do? Okay, you know that. Okay, we have to apply the, what do you have to apply? The law of conservation of momentum. Correct? So we will apply the law of conservation of momentum here. Okay, now what is the law of conservation of momentum? You know that it is of M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. That is the, okay, law of conservation of momentum. Now the law of conservation, by substitute here, what is the M1? In the place of M1 we will put 0.1, okay, kg into U1 is of 2, correct, plus, okay, M2 is of 0.2 into what it is 1, correct, is equal to, now again M1 means 0.1 into, that is the value of V1. Now V1 it is given that, okay, it is of 1.67. Okay, then plus 0.2 into V2 we have to find. Sure? Okay, now here in this value, that is where we are substituting, you understand this? Okay, that is here. Okay, we are substituting this value in this equation. Okay, now what it is, now this is of 0.2 plus this is of okay, also 0.2, correct, is equal to what this, the point will be shifted to here, that is 1.67, correct, okay, plus 0.2 V2, correct. Now this is of 0.4 minus what it is 0.167 is equal to what it will become 0.2 V2, correct. Now while subtracting, what is 0.4, okay, minus 0. What it is 167, correct. Okay, so from 10 7, 3, from 9, 3, okay, from 3, 1, 2, correct, 0.0. Okay, so it will become what it is, 0.233, okay, is equal to, here it is 0.2 V2, correct. So V2 is equal to what it is, 0.233 upon 0.2. Here we can multiply 10 on both numerator and denominator, so it will become 2.33 upon 2, correct, while dividing 1.1, that is 13, that is 6, okay, 5, okay, that much meter per second. Okay, this is the answer then. So you got to write, so the velocity of the second object is 1.67 meter per second. Understand? Please do fast. Okay, you take the, now if you want, so if you, so it is like this, sure. Then we will go to the, now it is the exercise. Now here look, an object experiences a net zero external unbalanced force, okay, that is there is no unbalanced force is exerting on it. Okay, that is, suppose that such a condition is possible only in where space. Okay, then is it possible for object to be travel with a non-zero velocity? Sure. Okay, yes. Okay, it is possible. Like if there is no, if a the body and object is in motion, okay, और बाहर से कुछ एक्सटर्नल फोर्स उसके ऊपर अप्लाई नहीं हो रहा है, तो ओबियस वो क्या होएगा, मोशन में ही होगा. तो अभी अपन एक्सप्लेन करने के टाइम बताया था कि अगर एक ऑब्जेक्ट रेस्ट में हो रहा है तो रीजन उसका क्या है, बिकॉज एक्सटर्नल फोर्स उसका ऊपर अप्लाई हो रहा है, जैसे कि ओके क्या है, फ्रिक्शनल फोर्स और द रेसिस्टेंस ऑफ द एयर एक्सेट्रा लाइक दैट. इधर वो कुछ नहीं है बोल रहा है, ऑलरेडी बोला कि नो एक्स्ट्रा जीरो, ओके, एक्सटर्नल अनबैलेंस्ड फोर्स. ओके देन, ओके, सो दैट ओके इट विल गो ऑन मूविंग. Okay, first state the, that is what the condition is. Okay, that is okay, if there is no external force, okay, क्या आएगा, it will go on moving. Okay, in the same magnitude on the, okay, then must be play same magnitude रहेगा और same velocity रहेगा. Okay, that is उसका जितना पहला उसका velocity में जो move हो रहा है वही velocity में move होते रहेगा. Okay, और direction भी क्या है, वो change नहीं होएगा. Okay, that is what the answer here. Sure? I hope you understand. Okay, so you can write the answer like this. Okay, then we will move to the next question. Now here, when a carpet is beaten with a stick, dust comes out of it. Explain. Okay, ये तो अपन already मैं जब भी explain किया था तभी ये बताया था. That is when we are beating a carpet. At that time, okay, what is there? The dust particle and the carpet. Okay, both are at rest. When we beat it, the carpet started to move, but the dust particle want to be remain in state of rest. Understand? That is due to its inertia. Now, when it is so due to the jerk, we can say that now the dust particle is remain there. Okay, now the carpet is moving. So you know that okay, these two, that is the dust particle will be separated from the carpet. Okay, and because of the gravitational force, okay, the dust particle will fall down. Understand? This is the answer of it. That is the main reason behind it is the inertia. Okay, so you can write the answer like this. The carpet with dust is the state of rest. Inertia of the object tends to resist any change in the state of rest or state of motion. When it is beaten with the stick, the carpet is set in motion, but the dust particle remain at rest. Due to this inertia of the rest, the dust particle remain in the position of rest and falls down due to gravity. Okay, write it down. Now the third question: why it is advised to tie any luggage kept on the roof of a bus with a rope. Okay, this also, okay, while explained, okay, I give the reason of this. Okay, that is, you know that when it is in motion, when the vehicle is in motion, okay, normally a bus, okay, which may not be moving with a constant velocity. Sometimes the speed will increase, sometimes the speed will decrease, depends on the acceleration. Okay, so अगर कभी कभी वो सडन ब्रेक भी मारना पड़ता है, तो at that time you know that okay, if it is not tied with the bus, now the inertia of the luggage, okay, and the inertia of the bus, it will be different. Okay, that is, the bus come to stop suddenly, okay, but the luggage is at rest and want to be at rest, understand? So it can fall down. Okay, like that, even taking the turn and also, okay, it can, okay, change the direction. Bus want to change the direction, but luggage will not change the direction. Okay, so in such a case, the luggage can fall down. Understand? In order to avoid this, okay, what we are doing is, we are, okay, tying it with a rope. Sure? Understand? Okay, the main reason is of here also, the inertia is the reason. So you can write the answer like this. Okay, you make a pause and continue. Now the next. Here, a batsman hit a cricket ball with which then rolls on the level ground. After covering a short distance, the ball comes to rest. The ball slows to a stop because the batsman did not hit the ball hard enough. Velocity is proportional to the force exerted on the ball. There is a force on the ball opposing the motion. There is no unbalanced force on the ball. Okay, so the ball would want to come to rest. Okay, here actually you know that the answer is of a third is the answer. Okay, third question is the answer. Okay, why? Because in all other case it is not. We know that when ball जब भी उसका ऊपर move हो रहा है, तो आपको पता है कि उधर एक frictional force है. Okay, वो frictional force का वजह से क्या हो रहा है? वो जो ball come to stop है. Understand? Okay, that is the answer is C. So you can write the answer like this. Okay, so I will continue. You pause it and write. Okay, then next question. Now here, a truck starts from rest and rolls down a hill with a constant acceleration. Okay, fine. Okay, it travels a distance of 400 meters in 20 seconds. Okay, so here, what we can say is the distance traveled, S is equal to what it is 400 meter. Okay, and time is given that it is of 20 seconds. Okay, find its acceleration. We have to find the acceleration here. Now one more thing is there. It is given that start from rest. It is given that it is start from rest. Rest means you know that it is U is equal to 0. Sure. Okay, so what we can say? Here we can say that S is equal to, what is S is equal to? Ut plus half AT square. Correct? So what is S is of here? S is of 400. Is equal to U is of 0 into T is of 20 plus half into, what is A is of here? Okay, acceleration we have to find. Again, T is of 20 square. Sure. So what it become? Now we can say it becomes 0. Okay, that is, you can write that is 400 is equal to, this becomes 0. Okay, here it is of half into 400. Okay, A. Now again it is of cancel, it will become 200. Correct? So that A is equal to 400 upon 200 is equal to 2, that is meter per second square. So you got A is equal to, what is the acceleration is of 200. Okay, now further what it is given that okay, find the force. Now they told to find the force also acting on it. If the mass is 7 metric ton, the mass is given that mass is equal to 7 metric ton. Okay, it means 1 metric ton is 1000 kg, that is 7000 kg, that is 7000 kg. Okay, now force, you know that F is equal to what it is, ma. Okay, so that force it is of 7, mass is of 7000 into acceleration is of 2. So it 7 2s are 14,000. Okay, what it is, Newton. Okay, so the force acting on the truck is 14,000 Newton. Understand? So that is about it. Okay, you can do it. Okay, like this also the same thing. Okay, that is if you are having difficulty in writing, understanding my handwriting, okay, I do like this. Okay, and then the same. So I hope you understand it. Okay, you practice it well. If any doubt, you can ask. Bye. Have a nice day. Take care.